Hello. Let's start. This is the first class for COMP3311 database systems. So I'm your lecturer, and this is today's outline. So first, I will introduce you the people running this course. So this is me, and the photo was taken one day before I got my haircut. And my name is Weik1 Li. And you can ask your Chinese friends about the meaning of the characters in my name, and it's actually every character has a meaning. And I'm the lecturer in charge for this course, and you can find my personal website here. And my previous experience was I got both my PhD and bachelor's degree in Nanyang Technological University in Singapore. And my research interest was actually not database. I was a software engineering person. And basically, I'm interested in software testing to find vulnerabilities and bugs in software systems. And recently, I'm particularly interested in large language model related topics. So what to call me? You can call me Weik1, which is my given name. You can call me Dr. Li, and you can call me YK. Actually, you can call me anything as far as I could recognize it. And this is the email. If you have any questions, you can drop me an email, or you can use the forum. So please don't use send emails to my personal email, because it's I receive a lot of emails every day. So it's better to send to this course email. And the second person to introduce today is Dylan. Actually, Dylan is our course admin here. He's in charge of almost everything other than lectures. And this is his photo. And this is the correct way of viewing his photo. So you can practice your neck with this photo here. So, and we have 13 tutors this year. Actually, you can find the timetable and tutorial groups with this link here. So, how will this course run in 24T1? So, actually, this course has been running here in UNSW for like 30 or maybe 20 or 30 years. I think it's older than all of you here, actually. 27 years. Oh, that's older than all of you here, but still younger than me. And how will this course run in this year, in this term? So this is the course website where you can find most of the information. So you can find the slides in this website, you can find the timetable, you can find the course outline there. And in this year, we are not using WebCMS for the forum. We use AdForum. I think it is a much better one. And as for recordings and my experience, you need to find them on Moodle or ICO 360, but you will need to log into your student account to access that. And as for the sources of information, we have lectures. This was previously how it was previously done. So we have lectures, we have videos, topic videos, where the primary contents are. And we have course notes, which are the more detailed version of the topic video slides. And we have textbook. There are many different sources of information, but in this year, we will do it differently. I will try to merge all the lecture notes, all the content, and all the knowledge inside. You don't need to take a photo, actually. You can find the slides on the course website. And I will try to put everything inside the lecture notes, and including the detailed content, including the summaries, including all the exercises and examples. But you will still need to access or maybe rent or buy a textbook if you want more details. And all the activities here are still the same. So basically, we have lectures we will cover the primary content of the course. We will walk through examples, and we will. You can also ask questions if you want, and we will also have tutorials where we can walk through the exercises, and you can ask questions to the tutors. And for practical exercises, I believe some of you may have already tried it. So it's actually to help you to learn the systems and skills, because this is although we are computer science, but we are essentially engineering students. We are still engineers. We need to make our hands dirty to learn things. So that's why it's better for you to try out all the practical exercises. As for assignments, it's also designed to practice your skills. And for exams, is to demonstrate your knowledge and skills. This course is, the exam is quite heavy for this course. It weighs 60% of your total mark. So, but don't hate exams. It's just to make sure that you can learn what you need to learn. So don't hate exams. And how are the slides organized this year in this term? So I've used some color codings and icons for you to quickly go through all the slides. In case, because most of you here, I believe you are good students. You attend the first lecture, but some of the students didn't even appear here, and I think for us, based on my experience before, some students will only look at the slides maybe 2 weeks before the final exam. So in case you do that, this can help you to quickly run through all the slides. So here we have a summary of knowledge. If you see this icon on the top left corner of the slide, you will know that, okay, this slide is related to a summary of knowledge. And if you see this yellow E here, it's related to some kind of exercise. So, but you may wonder, why do I use the color of blue and yellow? It's because some people are colorblind, so I intended to avoid red and green. And if you see this small icon here in a particular slide, it means that particular content inside the slide requires attention. So this is about the slides. And just like what I've mentioned just now, we are engineers. We need to make our hands dirty. So you need to make your hands dirty. You need to practice a lot. This course is it requires a lot of exercises. So you will need to run your own Postgres server on one of the cloud services provided by the school. So if you haven't set it up, you will need to do it, and you try to get this done before the first tutorial next week. And you can find more details of how to do it here in one of the resources. And some of you may have encountered some problems or bugs when you are trying to set up this morning. And we have fixed the bug, and Dylan can show you a lab demo of how to do this. If you haven't done this, please try to follow Dylan's step and try to set up your own server on the cloud service.
You'll have to excuse me, I have a cold at the moment. All right, so in the course, you will be using a database a lot. It's a database course. You are free to install a database on your personal computer. You are free to use whatever software you like. But in the exam, for the assignments, we'll be using Postgres. You need to be able to submit code that works in Postgres. Because of that, because we require you to use Postgres, we provide you with a way to use Postgres on a CSE server. The first thing you need to do is log in to a CSE server, and not just any CSE server, a specific server set up specifically for running your databases. You can do this with either VLab or with SSH. If you do use VLab to run this course, you will need to use SSH anyway. You cannot use VLab to go directly into the database server. You can use VLab to get into a normal CSE server, but from that point, you'll have to use SSH to get into the database server. So SSH followed by your ZID at d2.csc.unsw.edu.au. And then we wait, because my internet connection is very slow at the moment. Very slow at the moment. There we go. All right. We are now in the CSE server NWSID VXDB2. This is where we'll be running all of your databases. You should not be running any other coursework from this server. This is just for your databases. If you're a 2521 student or a 6991 student, you've got other work you need to do on a CSE server, you should do that on a normal CSE server. This server is just for your databases. Databases are large. They take up a lot of space. You don't have that much space on CSE. There we go. I have more space than you do because I'm a staff member. I have 10 gigabytes of space. If I tried to run a database with 10 gigabytes of space, I would run out fairly quickly. So on this specific server, we give you extra storage space. That extra storage space is located in a place called /local storage, followed by your ZID. That exists. You can just, if you are on this server, again, this doesn't exist anywhere else, only on this specific server. But on this server, you can go to this location, /local storage, followed by your ZID. And here is where you'll be setting up your database. At the moment, it is empty. I do not have a database. We provide a way to create the database very, very easily. 3311 PG init. That's it. That'll do all the work for you. I now have a database. There's my database. There were issues with this command earlier today. We think they have been solved. If you try to run this command, this 3311 PG init, and it doesn't work, let us know on the course forum, and we'll look into it. But hopefully it should now work. So we have a database. What do we do with our database? Well, first off, we need to tell the computer that we want to use the database. All of that information is in this file called env. All of this stuff up here is setting up our database. We need to use all this stuff. We do that with this command. Let's make that a little easier to see. Source, local storage, your ZID, env. We run that command, nothing happens. But we now have a database. TSQL is the Postgres SQL command. That's how we're going to be accessing our database. -L asks Postgres to list available databases. And I have some available databases. Let's make that a little nicer to look at. There we go. An empty database, there's no such thing as an empty database. We have 3 databases that exist automatically. The Postgres database, the template 0, and template 1 database. Don't touch those databases. These databases contain the core information needed for Postgres to run. If you modify these databases, your Postgres will break, and you'll have to recreate your database. If you do accidentally destroy your database, all you need to do is remove the PGSQL, so I've got bigger, PGSQL directory, just going to RM that, get rid of it, and then run 3311 PG in it again. It'll do all that stuff. And now our database exists again. So it should be that easy. Couple of other things. Databases take up a lot of space, a lot of CPU usage. We don't want you to keep your databases running when you're not using them. Well, there's a command, P0. P0 will turn off your database. Server stopped. When you are finished using your database, run P0, turn it off. It'll make the lives of everyone else in the course easier when they try to use their database. If you want to use your database again, you turn it back on with P1. Waiting for the server to start, server started. Everything will work. If you get an error that looks like that, when you try to use your database, cannot connect to server, you haven't started your database. Means you need to run P1. Started server, I can access my database. If you quit, you leave the server, I've left this, I'm now back on my own laptop again. If I go back in, and I now have to wait for the network connection again. If I go back in, wait for it, there we go. If I try to start my database, oh, it works. That shouldn't have worked. Let's do this. If I try to start my database, it doesn't work. If you try to start your database, that will be what happens. Why does that happen? We haven't told the server we want to use our database. How do we tell the server we want to use our database? With this command. So every time you connect, you need to run this command. Source, local storage, ZID, env. And then I can start my database and everything works. I'm finished. I turn off my database. I close. I do something else. Any issues? Post on the forums. We'll be more than happy to assist. All right.
I saw a lot of worried or confused faces just now. So can we have a quick show of hands? How many of you are familiar with Linux commands? Okay, around half of you maybe, less than half. And but don't worry about this. You will be learning how to use Linux in this course, and that's why I suggest you to try to get this done before tutorial 1 next week. You should try out all the commands Dylan just showed you, and don't worry if you can't do it. You can always ask us, or you can always ask your tutors during the first tutorial. So don't worry about this. So that's about how you set up a server on our local cloud service. So another thing here is, if you are not very familiar with Linux commands, you have an alternative way of trying out SQL, out everything here. So what you can do is, you can go to this website, which is actually here, and you can just write all your SQL queries and commands in this edit pad, and you just click run. You can get all the results here. So that's very simple, and some of the slides may have some examples that you could directly run in this website. However, I still encourage you to get familiar with the cloud service Dylan has just showed you just now, because you will have to do your exams on that server, and also for this web page, for one compiler here, you can only run one SQL file. So you have to create your database, you have to create your table, you have to insert everything every time you run the commands. So that's why I still encourage you to use and set up your own SQL server. And that's all about how this course will run in 2041. And here, let's jump into the real content of this course. So let's have a quick overview of database management systems. So the name of the course is database systems. Actually, it's not very accurate. The accurate name for this course is actually database management systems. So the definition of a DBMS is a software system that is designed to manage and organize data in a structured manner. It allows users to create, modify, and query a database, as well as manage the security and access controls for that database. So when we talk about software and when we talk about data, what pops up in your mind? Are you talking about Excel? So is Excel a DBMS? Yes or no, and why? If it is a database DBMS, why it is? If it is not, why it is not? According to the definition. So will anyone here volunteer to answer this question? Hi. Actually, probably is the correct answer here, but actually it's no. The most accurate answer is no, but probably means it is partially a database. So it's only a spread. You can manage tables, you can manage data. However, it lacks a lot of key features that a real DBMS should have. For example, it lacks data integrity check. You don't have these constraints to limit what you can put inside a table, inside a cell of an Excel table, right? You can put in almost anything as far as you can key in and type in. So there's no data integrity check, and there's no proper structure for tables in in Excel. You can almost put in different types of data in one column. You don't have restrictions on this. And also there are no relationships between different tables in Excel. You can't do that. And there's no keys. You can't guarantee that the data in one column is unique. You cannot do that. So that's why Excel is not exactly a DBMS. So probably it is partially a DBMS, but it is not. So what are the real DBMS? What are the different types of DBMS? So we have relational database management systems. PostgreSQL is one of the typical relational database management systems. So the data models of this type of DBMS is that they are organized. The data are organized in tables, different types of tables, and the key feature here is that how we should use structured query language to retrieve data from the DBMS. So this is the key features or characters of this type of DBMS. And the most typical examples are Postgres and MySQL. So I believe you have encountered this a lot if you have taken the software engineering class. And the second type of DBMS is object-oriented databases. So it combines the relational database concepts with object-oriented principles. So I believe most of you have taken the course of object-oriented programming. So basically, this type of database will keep track of all the data as objects. So it requires less code and is quite natural to keep things as objects. So that's why it is very popular nowadays, and I believe most of you have heard about it. And a typical example here is MongoDB. The third type of DBMS that is also very popular is called graph or network database. So these databases are used to store the data elements which are naturally organized like a graph. For example, you can have an organization graph of all the people here in UNSW. So you can put them as a graph. And then this kind of database is natural for it's easy to store the graph-like data, but it's quite specialized. So normally you don't use it. And a typical example here is Neo4j. And also there are some other types of DBMS. For example, many of you may have encountered Redis, which is a very fast in-memory database, and it can only store key-value pairs. It is fast, but it sacrifices the capability of storing complex data. And one of a new type of database is called vector database. So nowadays, large language models are very popular. And in order to make large language model enhance the capability of large language models, we have some kind of retrieval augmented generation. So which is to attach the AI model to a source of data. But we don't store the data as plain text. We store the data in a vector database, which are stored in embeddings. Because AIs, they don't accept plain text. What they receive directly from as input is actually embeddings. So they don't accept natural language. They accept vectors. So a vector database is used to store the vectors that is used as as the source of information for those AI models. So this is a new type of vector database. However, in this course, there are so many types of DBMS. However, in this course, we will focus on relational database management system, which is one of the oldest type of database system. However, it's still very popular. So you may wonder, okay, we have so many different types of databases. We have a lot of choices for NoSQL. We have a lot of alternatives. But why are we still learning SQL in 2024? Actually, this SQL language is 50 years old in this year, just 50 years old. I think it's even older than this theater. So there are many reasons for using this SQL. If you want to if you want to get the detailed reasons for using SQL, you can click on this link. However, personally, I think from my experience, SQL is normally much faster than object-oriented database management systems. So, for example, when you have like 10,000 or even larger entries in your database, SQL could be much faster than MongoDB. So that's one of the reasons of why we still need SQL in today. And it's also well-rounded, because when you talk about speed, you may think, okay, Redis is much faster than this because it's in memory. It only stores key value pairs. Why we need SQL if there's something faster? Because Redis cannot handle complex data structures. It can only store key value pairs. So SQL is actually a balance between speed, between performance, and capability of describing the data. And last but not least, it provides us a unique way of describing the world. Because we are programmers, we don't use natural language to describe the world. We use programming language to describe the world. So if you have learned object-oriented programming, you know that, okay, we can define things as objects, as classes, and it is an elegant way of describing and modeling the world, because it can help you to abstract the concepts. It can help you to organize things. So relational database provides us a unique way of describing things. So PostgreSQL or NoSQL, that's the query. So there's no single best database management system nowadays. It just depends on the requirements and situations. However, SQL has its own advantages. So that's why it is still popular, and that's why we need to learn this in 2024. So talking about providing a new way of describing and modeling the world, let's jump into the topic of how do we model data. And this is data modeling. So as you can see, there's a blue icon there on the top left corner of the slide. So it means this is a knowledge slide. And the aims of data modeling is to describe what kind of information should be contained in the database. For example, you need to define different types of entities, and like for example, we can have a database storing all the students. We can have a database storing all the courses, accounts, branches, patients, whatever. All the entities and their attributes are stored, should be described in the data model. And the second thing is, because entities are not just isolated, just like people here, you are not isolated, you are connected to someone else. So the entities could have relationships. you should include the relationships between different data items in your data models. So for example, John is enrolled in this COMP3311 course. So this is enrolled is the relationship here. And maybe Tom's account is held at Kuji. So is held at is the relationship here. So we need to find a way to describe the relations between different data items. And the last thing here is we need to describe the constraints of the data and also the relationships. So there are actually a lot of remember the difference between Excel and remember the difference between Excel and database system. Excel doesn't provide formal constraints on the data it accepts. So the key here is for data modeling, we also need to describe the constraints. So for example, for some IDs, it could have some numbers of digits, and we must ensure that these IDs must meet this criteria. And for example, there are also constraints on relationships. Maybe the student can enroll in no more than 3 courses per term. So that's the constraint for a relationship. So these are the 3 key aims of doing a data modeling. So we will be using this and applying this in our exercises later. So, and also, please remember that data modeling is a design process. So what's unique about design process? It's not an engineering or implementation process. So the thing here is, as a design process, there's no absolute correct or wrong for a design. It's just whether this design fits the requirements or not. So remember that, okay, this is a design process, and we need to convert requirements into a data model. And this data model doesn't have a global correct or wrong. So as far as you can justify why you make this decision, why you make this kind of design, it's okay. And the inputs to data modeling are maybe the enterprise to be modeled or the user requirements. And the outputs from the data modeling process is a semi-formal description of the database structures. And there are many languages and methodologies developed to assist this data modeling process. For example, you can have ER diagrams. You can have object design language for those object-oriented databases. And you can have even use UML to do data modeling. Normally, data models are categorized as either logical models or physical models. So logical models deals with the conceptual modeling of the information. It's more abstract. It's on a higher layer of the thing here. And physical models are actually more towards how we design how the data are displayed or stored in the database. For example, for SQL, the physical models are actually the schemas or the tables in the database management system. The logical models here are on a higher level. So they are actually so we focus on the logic model here because physical models really depends on the database management system you are using, and that's a different story. So there are actually 2 groups of logical data models. The first group is object-based models, so which is quite common if you are familiar with MongoDB. And they are record-based models. You could have relational records, you could have network or graph models, or you could have hierarchical data items. As for object versus record, so just now we discussed why we still need SQL, and object actually represents no SQL choices, and record-based data models represents SQL-based approaches. So object-based data models trace the database as a collection of entities of various kinds. It is very flexible, and it is very natural to describe and model the different things. So why it is flexible? Because it's only a collection of different objects. For each object, they don't need to have exactly the same structure. If you use a MongoDB, you can build a collection, and you can put in almost anything, and these things don't need to look the same. For example, you can put in a car into a collection. You can put into a ship into the collection, and they don't need to have the same properties. Cars could have wheels, but ships don't have. So that's why it is very flexible. However, this flexibility may cause trouble when you use it. When it is you have saved the effort of storing the data, but you will pay extra efforts when you query and retrieve data from the database. So this is about object-based data models. And for record-based data models, we treat databases as a collection of fixed-sized records. It is less flexible because a typical example is tables. So if we put things inside a table, whether this thing has a property contained in the column or not, it will need to have that column there. So you can put in null in that column. You can put in empty. You can put an empty column there, but it will always have that column for a record. So it is less flexible, and however, it is normally closer to the physical layer, to how the data is stored, and it is much easier for us to implement efficiently. So this is one of the reasons of why PostgreSQL or these SQL-based data DBMS are faster than MongoDB. So this is these are the advantages and disadvantages of objects versus record. And a common design idea is it's natural for us actually to think in an object-oriented way to describe things, to model things. However, it is hard for us to use entity or relational thinking to describe things. So a useful strategy here is, first, we could, if we want to design an entity relation model, we could design first in an object-oriented model first, and then we convert it into a record-based model. So this is actually a very common strategy to adopt in this course. So before we jump into the exercises, let's go through these key things to take note. So the first thing here is we start simple, and you don't have to design. You don't have to make a design choice and never change it anymore. We could start from a simple point and iteratively improve our design. And then the second thing here is, normally when we do a design, we identify objects and their property first, and then we look into the relationships between the objects or entities, and after that we consider and think about the constraints of the objects and relations. And And the third point here is most designs involve different types of classes, different classes of people or actors. So we should think from the people or actors' point of view when we design data models. And the first is keywords in requirements normally suggest data and relationship. So for example, nouns are normally used to describe data, and verbs are used to describe relationships. And the last thing here is we should consider all possible data, not just what is available. So before we jump into our first exercise, let's have a 10 minutes break. And I hope I could see you again after the break. And I think some of you have left and maybe will never come back again for this session. I hope you will come for the next session, but let's have a 10 minutes break and hope to see you after 10 minutes. If you are hungry, you can grab some snacks here. Don't be shy. But if you are sleepy, don't grab a snack here. I should have brought more snacks. I didn't expect this, but actually I just saw this sign here: no eating or drinking in this lecture theater. But don't worry, you are not recorded. I'm the only one who's recorded here, so you can eat it. Don't worry. Sorry, I'll down. Yeah, sorry. Hello, class. I think after 10 minutes we have lost some data, and but we also have some reordering of data. Some students moved their seats, and this is let's start the second half of this lecture. So remember what we just covered now. So what are the three key aims of doing a data modeling? What are the three key aims? You can't find the answer on this slide. So the three key aims of doing a data modeling are: first, we need to describe what kind of information to be stored in our database. So this is the first thing. The second thing is, since we have objects, since we have pieces of data, what about their relationships? So the second thing here is we need to store the relationships. We need to think about how should we model or describe the relationships between different pieces of data. And third, since we have data items, we have information, we have the relationship between the data items, we need to think about what are the constraints of the data items, what are the constraints of the relationships. So that's the third key aim of doing a data modeling. And bear this in mind, let's go through this first exercise. So the first exercise, here are the requirements. So imagine we want to build a database for course outlines. So we need to work out the requirements by looking at some real course outlines. And we need to develop an informal data model by identifying the three key things. The three key things are corresponds to the three key aims of doing data modeling. So let's have a quick look at what are the courses, what are the key items in a course outline. So as you can see here, we have some posts on our forum, but you should use @forum later on. So we have already sorted that out, and let's try to move everything there. And sorry. So if we quickly go through the course outlines, we can see that, okay, here are the different things. We need to have some key information for a course. We need to have a course in a course outline. We need to have assignments. We need to have schedules for the classes. We need to have students. We need to have staff. So these are the key things to consider in the course outline. So let's jump into the thinking process. So remember the best practices to follow. So we need to start with objects first, and then think about their relationships. So just now, I hope you have grasped, you have an understanding from our course website of what are the key objects. So what's the most important object for a course outline? Of course, course. And let's think about what are the attributes of a course. A course should have a code. Like for this one, we have a code 3311. A course should have a name. The name of this course is database systems. A course should have some descriptions. These are the key attributes of a course. So what about all the people here? What about the lecturers and students of the course? Should we put them as an attribute in the course? Should we put all the people here as an attribute in the course? Some of you have shaking your head. Why no? Yes, yes. That's one of the reasons. Because these people here, they have their own attributes. If we store them as an attribute, how do we store their attributes? We don't store attributes of attributes. That's not possible to be stored as a table. So they have their own attributes, and they have relations with, they are involved in some kind of relations with courses, because a student can take many different courses. A lecturer can teach many different courses. If we want to store them in a course, we need to, it's a multiply relation. So it's like student A taking course B, student taking course 1. Student A is also taking course 3. If we want to store them as plain records, we need to have 2 records for the student and course. And if we put this in a course, we will waste a lot of space. So that's why we better not to put lecturers and students in a course. So let's make users a separate class of objects. Following this idea, what are the key attributes of users? Let's think about it. What are the key attributes of a user in a course outline database? Name, yes. Yes, correct. Are there a lecturer or student? But we don't put this question as an attribute. We put the roles of the user. Actually, in our particular situation here, we are considering building this database for UNSW, so we also include ZID. So a user could have a ZID, a name, an email, and the type of the user. The type of the user refers to whether this user is a student or a lecturer or maybe a tutor or a course admin. We could have different attributes for a user. So what else objects do we have? So remember the website I just showed you. What else objects are involved in this course outline database? So let me do the answer here. So we have 500 students enrolled this term, and they are divided into different classes. So you could have different types, different classes. So the class could have a type, whether it's a lecture or a tutorial. The class should have a day. So like today is 12th February, so it should have a day. It should also have a starting time and ending time, and it should also have an attribute of the location of the class. So this is the first extra object we have. The second one here is, just now you see on our course outline, we have a few assignments. So each assignment must have a name, whether it is a quiz, whether this assessment is an assignment, whether it's also an exam, and these assessments should also have descriptions and weight as well. For this course, remember the weight of the final exam is 60%. And you should also have due date for each assessment. So that's all about the objects. Wait. So now we have all the objects here. We have courses, we have users, we have classes, and we have assessments. Maybe there are more objects, but let's keep things simple right now. So since we have all the objects here, what about their relationships? What about the relationships between all the objects? Yes, yes. I heard some students, actually both of you mentioned users and cars. Actually, it's very hard for us to imagine the relationships of all the different objects in our mind. So we better write them down in a table. So let's go through the diagonal line first of this table. So the first one is what about causes and causes? Do they have any relationships? Sorry, I might stop this animation. So do they have relations between causes and causes? Actually, I just showed you there are relations, but some students are still shaking their head. I don't know why. But the thing here is there are relationships between causes. So some causes are prerequisites for another cause. So you have to take one cause first before you take the second one. And some causes are actually equivalent to each other. So this cause is an undergraduate version of the database system. Actually, there's a postgraduate version of database management system, DBMS course, which has a course code called 9311. So some courses are equivalent. So these are the relationships between courses. What about users and users? Do they have any kind of relations? In a course outline system. I heard some people say classmates. Yes, actually, there could be this kind of relation, but we could use some other relations to represent this. Because I'm teaching 3311, and you are learning 3311. So we don't really need a direct connection between you and me. We are connected through 3311. So let's put no relation here. So, but remember, this is a designing process. As far as you can justify your final design, it's correct. There's no global correct or wrong. But let's think through this process. Let's do this reasoning and make sure that what you are thinking is reasonable. So maybe you think, okay, some students are you have friends, you have classmates, but for course outline system it's not needed, or it's not a must-have. So what about classes? What about the relationships between classes? So like tutorial 1 and tutorial group 1, tutorial group 2. So do they have any relations? Yeah, I see some people are shaking their head. So there's no relation between classes in this course outline database. So we don't really have relations between classes. So that's this one. What about assessment? Does assessment have relations? Actually, also no, because one assessment doesn't affect the other one. You can skip all the quizzes, but you can still take the final exam. So you don't have to. They don't have any dependencies or relationships. So that's the relationships between assessments. Oh, sorry, I messed up again. And what about courses and users? Actually, just now some students have mentioned this type of relations. Yes, there are, for students, some students may take the course. And for some users, like lecturers or course admins, they teach the course. So there are two types of relations. One is a user can take a course, and the other one is a user can teach a course. So what about courses and classes? Do they have relations? Yes, yes, of course. Of course they have. A course could have different classes, because if we put all the students in one class, it's too big. So a course is separated into different classes. So a class could be belonging to a course. So this is the relation here. So what about courses and assessments? Do they have relations? Yes, yes. It's actually the same. But since we try to avoid using the same term here to avoid confusion. So yes, an assessment could be part of a course. So this is the relation here. And let's think about the relationships between users and classes. Do they have any kind of relations? Yes, yeah, you're so fast. And actually, yes, students can get enrolled in a class. And a user could be in charge of a class. Like, for example, I'm in charge of this lecture here, and the tutors will be in charge of each of the tutorials. So these are the two relations between users and classes. And what about users and assessment? Do they have any relations? Remember, the context is a course outline system, course outline database system. So do they have any relations here? And that's a valid point, but remember, this is a course outline system. So we don't mark students in a course outline system. So that's why, although it makes sense, they don't have relationships here under this context. And lastly, classes and assessments. Do they have any kind of relations? The answer is no, because assessments have nothing to do with classes. So now we have a lot of relations. We have prerequisite. One course could be the prerequisite of another one. We have equivalent. One course could be the equivalence of another course. And we have the relationship of take. A user can take a course. A user can take a particular course. And we have the relationship of teach. A user, like a lecturer or a tutor, can teach a course. And we have the relationship of belong. A class could be belonging to a course. And we have the relationship of part of. An assessment could be a part of a course. And we have the relationship of enrolled. A user is enrolled in a class. And lastly, we have the relationship of in charge of. A user, like a lecturer or a tutor, could be in charge of a class. So these are the relationships. So just now we were thinking about, okay, we have a lot of objects. Objects can have attributes, but can relationships have attributes? So these are just now the relationships are having some kind of attributes which are made of the key actors between the relationship. But what can they have extra attributes, or do they need to have? The answer is yes. For example, for this teaching relation, a user could be teaching a course, but what is the role of the user? Maybe the user is a tutor, or the user is a lecturer. So just now you see Dylan. Dylan is a course admin. He's also involved in this class, in this course. But what is his role? What's the difference between Dylan and I? So we could put an attribute called role for this relation of teaching. So after putting role into teach, this is now what we have. So it looks quite tedious. Can we trim or optimize some relationships? Can we do some optimization here for our design? Not exactly, because a course is different from a class, so they cannot be merged together. So this comes with the previous question we were about can we put users as attributes to courses? So we need to think about the nature of relationships. Actually, we can put some actors in a relation as an attribute of some other objects. So let's go through the relationships one by one. So we can turn some of the relationships into attributes to save space. So for prerequisite, so one course, this actually is the relationship here is many to many. A course could be a prerequisite for many courses, and a course can have many courses as its prerequisites. So if this relation is many to many, we better not to put them as an attribute, because imagine if we are doing a table, we need to create multiple rows if we want to put them into one table. So we better not merge them together. So what about equivalent? Actually, this is also a many-to-many relationship. So a course could be equivalent to many other courses. So this is not suitable for optimization here. What about take? Actually, also no, because a course can be taken by many students, and the student can take many courses. So this is also a many-to-many relation. And same goes for teach. A course can be taught by many different people, and a lecturer or a tutor can be teaching many courses. What about belong? Course and classes. Can we optimize this relation? Actually, the answer here is yes, because a class is redundant if it is not attached to any a class is redundant if it is not attached to any courses. It relies on the existence of a course. So imagine we have a class, we have a tutorial class, but it is not attached to any courses. Then why should we have this class, right? So we can actually put the course as an attribute for a class because the class relies on the existence of a class. What about part of? Can we optimize this relation? Yes, actually it's very similar to the situation of belong because an assessment is not meaningful if it is not attached to a course. So let's say we have a final exam, but this exam is not related to any of the courses, then it's not meaningful. So that's why we can put the course as an attribute for an assessment. What about enrolled? Can we optimize this type of relationship? Actually, the answer is no, because one class could be taken by many users, and a user can take many different classes because you can take both a lecture and a tutorial. So it's a many-to-many relationship, and classes and users, they can exist without the relying on the existence of one another. So that's why enrolled cannot be optimized. And lastly, in charge of, it's actually very similar to enrolled, so it cannot be optimized in this case. So just like the reasoning process we have done just now, the relationships of belong and part of are one-to-many, and one entity of the relationship relies on the existence of another entity. So that's why they could be optimized, and we can turn them into attributes to save space. So we can make these changes as optimizations. We can simply remove the relationship of belong, and we can put the course, the course for which the class is attached to as an attribute of the class. And we can also remove the relationship of part of and make the course of that assessment as an attribute. So this is the optimizations we can do, and this is what we have now. Now we have the objects, entities, and their relationships. What's the third thing? Do you still remember the three aims of doing data modeling? The last thing we need to do here is we need to think about the constraints. So this is what we have now. Let's go through the constraints here. So for course code, we can safely limit the size of the course code to 10 characters. So I believe no course here in UNSW has more than 10 characters as their source code. And for name of a course, we can limit it to 20 words. So this is the limitation. This limitation is not only about the type of the attribute, it's also about the property of the attribute. So the type of the first attribute is it should be a character, it should be characters. The second one is it should be words. So there are two types of constraints for attributes. And for description of a course, we can limit it to 100 words. And for ZID, we can use 10 characters. And for usernames, I prefer to give it a very long user limitation because some people may have a very long name, and I don't think anyone here can pronounce his name correctly in this class. And but 80 characters is normally safe as a username, but as to store a person's name. But you can actually search for the word record of the longest name. It's actually longer than 80 characters. It will surprise you, and some of you are already searching for it, I think. And for email, the constraint here is quite special because we want the email to follow a valid format. It should be a valid email. And let's put 100 characters for this length of the email. And there are types of users. This is also quite special, the constraint here. It should be a fixed list of options. We shouldn't allow the users to type in any words or characters as their type. We should have some fixed options for the type. For example, we should have student, we should have academics, we should have admins, but we shouldn't allow the user to type in some random words. For example, some people may say, okay, I'm the king of this course, I'm the queen of this course. That's not allowed. So that's why we should provide key options to the users as the constraint here. So this is another type of constraint. And for course, this is also quite special, the course of the class. So because a class relies on the existence of a course. So this course here, the constraint is, it must be a course code or maybe some other unique ID of a valid course in the database. So we should have courses first before we have classes. So this is the constraint of the course attribute for the class. And for assignments, let's skip the name description. And for weight, we should have, it should be a digit. It should be a digit between 0 and 100. So remember, the constraint could have two types. So the type of the attribute is a digit, and the value of the value of the attribute should be between 0 and 100. And as for due date, it should be a date type of data. So that's all about the constraints for the objects. And what about the relationships? Do they have any constraints? Actually, there are many constraints for relationships. Let's just give one example here. So the example here is a user cannot take a course twice. So there shouldn't be two records in the take table with the same content. So this is the end of exercise 1. This is how we reach the design conclusion. Remember, this data modeling process is a design process. It doesn't have an absolute right or wrong. So you can make your design, you can have your own design, you can have your own opinion, as far as you can justify why you are doing it, as far as you can provide some reasons of your decisions. And this is just a showcase of how we can do this reasoning process. So let's come to the exercise 2. Consider the Gmail system or any other modern mail client. So what are the key objects? What are the relationships between the objects? And what are the constraints of the objects and relationships? So since we have went through exercise 1 in detail, let's quickly go through exercise 2. So the thinking process here is, let's come up with the objects first. So what could we have in email system? So the key objects here are the messages or the emails sent through this system. Messages could have title, could have date, could have content, could have a lot more other attributes. And there are users in this email system. They have their email address, they have their name. And there could also be labels which are related to the messages. Some emails could be spam, some could be junk, some could be very important. So there could be many labels for the messages. And let's think about the relationships between these objects. So between messages and messages, do they have any kind of relations? Yes, yes, that's correct. And what about one message could be a reply to another one. So this is a valid relation between messages. What about users and users? Do they have any kind of relationships? Yes, I heard some people said yes, and they are nodding their head. So what are the relationships? Employee of actually for email systems, they could have some frequent contacts. Maybe a user is a frequent contact of another one. Maybe it's a previous contact of another one. So these are some possible relationships between users. What about labels? Labels between one label and another one. Do they have any kind of relationship? Actually, no, right? Labels are quite independent. What about messages and users, between messages and users? Do they have any kind of relations? Yes, users can send messages. And yes, users can receive messages. However, users can send messages and users can receive messages. These two relationships sounds quite valid, right? But can we optimize two of them or one of them into attributes? Can we convert one of them into an attribute? A user can be a sender of a message. Actually, here there's a basic logic behind this system. Messages are not valid if they don't have a creator. Even if a message is a draft, it must be created by someone. So it should be attached to a user. So we can put, actually what we can do here is we can put user as an attribute called creator for the message. So how do we differentiate a sender of a message or just a creator of a message? Actually, we can use another attribute called is draft or is sent. So if the message is just a draft, then the creator is just the creator of the message. If the message is not a draft or it is sent, then the user is just the sender of the message. So in this way, we don't really need the send relation between users and messages. However, we can keep a receiver because a message can live without a receiver. So what about labels and messages? Do they have any kind of relations? Yes, yes. A message could have different labels. A message could be a spam message. A message could be a junk message. It could be marked as important by the user. So a message could have many different labels. What about users and labels? Do they have any relations? Actually, yes. Actually, no. Actually, yes, because the users can create different labels. They can create their own labels. So this is actually a simplified version of all the relationships here. As we just discussed, we can have sent by, we can have received by, we can have belongs to. So, however, we can optimize the sent by as a content to make the sender of the message as an attribute called creator for the message. So now we have the objects and the relations. We can think about the constraints. So for title of the message, we can have a limit of the words. For date, it must be a date time type of information. And for content, we can limit it to 1,000 words, so and so on. So this is a process of optimizing the user, the send by relationship into the creator of the message. So because a message must have a creator to live in the system. So this is how we can optimize this design. But please remember again, data modeling is a design process, and you can have alternative answers as far as it makes sense. But please do remember, you must do the reasoning, you must do the rigor reasoning, you must do it carefully to make sure that every step could be justified. And that's all for today's lecture. And I don't have more snacks, so to not avoid your dinner, to not affect your dinner. So yeah, so that's all for today's lecture, and thank you. If you have any questions, please feel free to ask me right now or on the forum.
Putting like, you know how you said you could optimize it by putting course as an attribute of, was it assessments and classes, right?
Yes.
Does the course in that in the attribute of class and assessment have attributes?
Attribute is like you just put one piece of data because when we put course as an attribute of a class, we only put the unique ID of the course.
Oh, okay.
Of that,
and
because
so
we don't want to put the entire record in all the rows, all the columns. As
right. Okay.
Yeah.
All right. Thank you.
So
directory in the terminal, but like it was working for my friend but not for me for some reason.
Oh, okay. Let me see. So
Like I did the source, the command, yeah. Like I'm logged into the.
Oh, I see. Because I need to go to
Local source, yeah.
what you didn't do it. Then you can see
Oh, okay, yeah.
just now you didn't run this
Okay.
command, so you don't have it.
And then if I were to like exit and do P0, would that work?
No, because you have to run it once.
Okay, I'll be running once. Bag like. Oh, thank you.
Actually, it's already set it up correctly.
Oh, it's working?
Yeah, it's working now. You have all the.
Okay, and I'm not supposed to
here.
use it.
Yes.
Okay.
Provided a command, but the P1
The first time you run it, last time I think they should have the same process of pressing this thing up, but please do a screenshot on other places. You can, do you know what is it for?
the ED one or
Yeah, the ED. You can also do it on the website.